Hi, this is Mrs. Lemoyne again, and we're going to do Grade 5, Unit 1, Lesson 4, Use Layers to Determine Volume. Our lesson goal today is to relate multiplication to how we use layers to find volume. So here's our warm-up. How many cubes? We're going to estimate how many cubes it would take to build this prism. First thing we're going to think about for me would be how many cubes I can actually count in this picture. And I can see that I have a front layer, and that front layer has 3, 6, 9. So in this layer right here, I have 9 cubes. And then I notice that there are more than just one layer, right? So I have 1 layer, 2 layers, 3 layers, 4 layers, 5 layers, 6 layers, might even be 7 layers there. So an estimate that would be too low would definitely be 9. Oh, let me get a pen that works. Here we go, 9. Another estimate would be 18 because I know that there's more than one layer there, so 18 would be too low. What would be just right? About right. Let's see. Well, there are 9 in each layer, and we counted again 1, 2, 3, 4, 5, 6. So it's hard to tell. Maybe 6 layers, that would be 54. There might be 7 layers, so 9 times 7, 9 in each layer and 7 layers, that's 63. I'm going to say about right would be between 54 and 63. Because this is an estimate, I can give a range like that. What would be too high? I think it would be 100 be too high. Anything over 63 might be too high. Yeah, I think that's about right. Remember, these are estimates and I can be wrong. It's okay. Because I can't really see. It gets really blurry back there. All right, let's go on. Why are not multiples of 9 good estimates? Well, we saw in that first picture that each layer had 9 in it. So any multiple of 9, if I have 2 layers of 9, it would be 18. 3 layers of 9 would be 27. 4 layers of 9 would be 36, and so on. So multiples of 9 are a very good estimate. What information would help you find the exact number? Well, I need to know how many layers there are. How many layers? I have to know that number to find out the exact number. Okay. If you've changed your mind, you can go back and revise your estimate if you want. But remember, estimates, you can be wrong if you need to be. All right. What do we know about the volume of this prism? Well, I can see that there's a big object here, and we have some missing cubes filling up that prism. So let's see, what do I know? I know that there are 2 across here, and there are 1, 2, 3, 4, 5, 6, 7 right here. So that means in this bottom layer, there are 14 cubes. I know that. What else do I know? I know that it's 3 high, 1, 2, 3 high in its height, but I also know that it maybe could fit 3 more or maybe 2 more. I don't know. I need to know how many more it could fit going up or how many layers I could build in order to fill up that prism, in order to find out the volume of that prism. I can't see how high it is because we have some missing ones there. Right. Our next activity, we're going to do layers in the rectangular prisms. We're going to complete this table, and we have to be prepared to explain our reasoning. So it looks like I need to look at prism A, color here that you can see. Prism A, I need to know the number of cubes in one layer. So let's see, 2, 4, 6 in one layer, and the number of layers. 1, 2, 3, 4 layers. So that would mean I would have 4 groups of 6. So if I just multiply those, I get a volume of 24 cubes. Okay? I could have done that a different way. I could have done layers such as, let's see, let me erase just this markings here. I could have looked at it as this front. How many are in this front? 1, 2, 3, 4, 5, 6, 7, 8 in the front. So let me get a different color pen for that. I could have said there are 8 in the front, and there are 1, 2, 3 layers of 8, and I would still get the same answer. 8 times 3 is still 24. So I could have done that in 2 different ways. I probably could have done that in another way as well. I could say, okay, how many cubes are in this layer here, or this column? And how many layer, and there are 2 of those columns. So there's a lot of different ways I could have found that out. So let's look at prism B. I only need to do it one way, but I'm showing you several ways. I'm going to do another layer. I'm going to say what the top layer is. So how many cubes are in this top layer? I have 1, 2, 3. 1, 2, 3, 4, 5. So that means I have 3 by 5, which is 15. And I have 2 layers of 15, which is 30 cubes. Another way I could have done that is I could have said there are 1, 2, oops, get a pen you can see, 2, and there's 3 here, 3 groups of 2, which would be 6, and I can see that, get rid of this marking, how many groups of 6 do I have? 1, 2, 3, 4, 5. So I have 6 in the front, and I have 5 groups of 6, which is the same as 30. So I have 2 different ways I could have done that as well. Prism C has missing cubes, but they want to know how many it would take to fill up the whole thing. So I'm going to do again, how many in one layer? Well, I could see there's 2 here, 4, 6 in the bottom row. So 6 in the bottom layer, and there would be 1, 2, 3, 4, 5 layers. 6 times 5 is 30. Again, there are other ways you could have seen it, but that's the way I saw it. For prism D, I have 1, 2, 3, 4 cubes, and I have 2 rows of 4, so that's 8 on the bottom, 8 in the bottom layer, and then I have 1, 2, 3 layers of 8. Oops, 3 layers of 8, Mrs. Lemoyne. 8 times 3 would be 24 cubes. All right, so I've just found the volume by using multiplication and counting layers instead of having to count each and every cube. That makes my life much, much easier. Let's see what's next. How can we find the volume of any rectangular prism? Well, I can multiply one layer by the number of layers. We can call a layer a base. So I can multiply the base times how many bases there are, or how many, I'm going to say how high it is, the height. That's one way we can find out the volume. Let's write that correctly, Miss Lemoyne. That's better. I could also say the length of the front times the width times how high. So we have lots of different ways we can find the volume of a figure. We can multiply one layer, the base, by the number of layers, the height. Base times height. We can find the length and multiply that times the width, and then times the height. Awesome, that makes my life easier as well. So it will not be real hard to find the volume from now on. All right, so here we go. Let's talk about what we learned today. It says, how do these two expressions represent the volume of prism A? So when I look at this expression, I see the number 2 and I see the number 12. Where is the 12 and where is the 2 in this prism? Well, I see that I have a 2 here, 2, 2, 2, right? And then where's 12? Well, if I count just this layer here, let's see, this is 3, 3, 3, 3. Well, that's 12, isn't it? And I have 2 layers of 12. That's how I would represent this multiplication problem. 2 layers of 12. Then it says, how does it 3 times 8 represented by this? Well, let's look at it again. 3, I see 3 here, and 8. Where do I see 8? 2, 4, 6, 8. There's an 8. This middle row is another layer of 8. And then there's another layer of 8. Well, there's my 3 times 8. I have, let's clean this up a little bit as I was thinking. I have a width of 3, and I have this area of 8, or a base of 8. 8 times 3 is the volume of this prism. So how does thinking about layers help us find the volume of prism that are not completely filled? Well, we can use just one row or one column to help us figure out the volume of the rest. That's pretty easy. Finding volume in different ways. Explain or show how you would find the volume, how 5 times 24 represents this volume. Well, again, I'm going to have to look for those factors. Where's the 5 and where's the 24? Well, I can see that there are 5 layers, and if I cut the prism horizontally, each layer has 24 cubes. So let's do that. 5 layers, 1, 2, 3, 4, 5, and each layer has 24. There we go. Then it asks, how do we show 6 times 20? Let me think. Where is the 6 and where is the 20? Well, there are 6 rows, aren't there? 1, 2, 3, 4, 5, 6. Does each one of these have 20 in it? Let's see. 1, 2, 3, 4. Where's my 5? 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, it does have 20. There's 5 layers and there's 4 length or width. So this thing right here is 20. This whole thing right here would be 20. Again, 20. And as you can see, there would be 6 20s. 1, 2, 3, 4, 5, 6 20s if you counted all of them. All right, we're getting there. Let's see if we can think of a different way to calculate this. We did 5 times 24, so we did each layer, and then we did each column. So there were 20 in each one, there was 24 in each one. What else could we do? Well, how many are in the front? Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 times 5 is 30. If the front has 30, then this layer behind the front would have 30. How many of those layers do we have going back? We said 4, right? So let's do 4 times 30. 4 times 30. We should get the same answer for each way we did it. Let's check that out to make sure our work is correct. Well, I know that 3 times 4 is 12, and I can just add that 10 there. So that's 120. 5 times 24, so I could do 5 times 20, which I know is 100, plus 5 times 4, which is 20. Oh, that's right, it's 120. And for this one, I can say 6 times 2 is 12, and then add that 10 in. So yeah, I got 120 cubes for each way I did it. And then it wanted that calculation while I showed it up there. So I can do this. 30 times 4 is 120. Can you think of another way to do it? Maybe you can. All right, let's move on. We just talked about that one. How does this prism represent the expression 5 times 4 times 6? Well, let's fill in the dimensions of this one. I have 1, 2, 3, 4, 5, 6 going across here. 1, 2, 3, 4 going back. And 1, 2, 3, 4, 5 going up. So if I multiply all 3 of these together, there's my 24 from the last problem I did. Remember we did 5 times 24. So if I multiply these 3 together, I should get the same answer I got before, which was 120. So that means, remember, this is the length, this is the width, and this is the height. This is how tall it is. So what if I came up with a way to do any prism? Remember we wrote that in the last time. Length times width times height. Or I could find out how much was in this base and multiply that times the height, which would be 5. And I would always get 120. That makes life much, much easier. All right, let's see what we have next. Same thing for this one, right? We found the length, the width, and the height. And any way we do it, we can always get the right answer. And this is the same as doing 6 times 20. Remember those groups of 20? 20, 20, 20. We could go on and on. All right, we talked about this. Let's see how many layers they gave us. I knew, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 9. So there are 90 in there. What is a multiplication expression? Well, we just wrote one. How does the expression represent the volume? I have 10 layers of 9. So there we are. Back to the warm-up. Okay, here's our cool down. If the rectangular prism was filled completely, how many cubes could it hold? Well, today I learned that if I take one layer, find out how many is in that layer, and we call that the base, I just need to multiply by how tall it is, the height. Remember that? So let's find out how much is in this layer. There are 2 here, 4, 6, 8, 10, 12. Or we could say 2 times 1, 2, 3, 4, 5, 6. So the base has 12. Let's see what the height is. 1, 2, 3, 4, 5. And I know my 12 times tables. I know that 12 times 5 is 60 cubes. If I didn't know that, remember we could go back and do 10 times 5 is 50, plus 2 times 5 is 10. And that would give me my 60. And there's my 12 times 5. Okay, last problem for this lesson. Explain or show how the expression 3 times 8 represents the volume of the cube. Well, I see groups of 3. and I see a group of 8. So I'm going to say that this 8 is my base and the 3 is my height. So 3 is the height times the base, which was 8, is how I would find the volume, and that would be 24 cubes. Cubes. Ooh, I messed that up. Let's do that again. Cubes. And there we are. We are done with lesson 4, and we learned a whole lot. All right, thank you.